Good morning, everyone. Thank you very much for making the time this morning to indeed speak about what is the projection until 2030. 2030 is not that far away if we think about it. Hydrogen is a massive topic for the path for net zero for the various European countries. So we will speak about three topics today, basically. On the one hand, what are the EU targets and where do we stand today? And then looking at the projections, on the one hand, where does Aurora see the demand developing, not only until 2030, but also until 2050, and where will the different supply sources come in our different scenarios, and how does that match up with the current pipeline that we are seeing on the electrolyzer side. So as a summary, where do we stand today? So we can see there's the big the Repower EU targets from last year that have been set not only in order to accelerate the ambitions for the EU to decarbonize quicker, but also as a response to the new world, the new geopolitical situation with the invasion of the Ukraine. So the target is for hydrogen to play a big role in decarbonization, 20 million tons of renewable hydrogen by 2030 for the EU, of which half are planned to be coming from imports and half in domestic production. And when we compare that now with where do we stand today, we can see that only a very, very little fraction of what will be needed by 2030 in terms of renewable hydrogen is actually already being produced. So we can see the task is quite massive, and this is also the reason why now, both on a regulatory level, there have been a lot of discussions on how can we accelerate the hydrogen economy, but also we see a lot of market players really picking up the discussion, closing MOUs and so on in order to get the projects on the road. Now, looking at the demand side, and here basically showing two scenarios. On the one hand, we have the Aurora Central scenario, which is basically our best guess on how the future of the energy systems will develop, the interaction between power, hydrogen, and the different demand sectors. And we compare that to our net zero scenario, which is a target scenario. So it's not a market-driven best guess scenario. It's rather what needs to happen in order for the EU to actually reach net zero in time. And what we can see here today, these are the demand sectors for the heating sector, the transport sector, and the industry. It's quite important to note that we haven't included the demand for the power sector here on this slide. And you can see that today there is already a demand for hydrogen. There's a lot of industrial processes that already are using hydrogen for, but in that case, gray hydrogen. So there's around 8 million tons of hydrogen already being used in the industrial sector today. It's not being used in heating and in transport in a significant way that we can see it here on the graph. For 2030, we see it pick up, right? So we especially see a pickup in the transport sector slowly, but also in the heating sector, and more industrial processes already using hydrogen as an additional pillar for the decarbonization for everything that cannot be electrified. So, for instance, an uptake for the ammonia production, but also the refineries are using green hydrogen instead of gray hydrogen, so we already see a move there. But then there is a big step until 2050, and this is really the vision that the industry has. Hydrogen will play a major role, and we do see quite a big difference between our central and our net zero scenario. In central, it's about double the amount of hydrogen demand that we see compared to 2030, and for the net zero, it's even 3 times as much. The big difference is in the transport sector and in the hard-to-abate sectors. So in the net zero scenario, the ambition is really to decarbonize the full industry. In our central scenario, we don't see this happen completely. So the central scenario does not reach net zero because there's a lot of components that come into it that make it, in our view, for the moment unlikely to reach net zero. So it shows quite well the gap, especially in the transport sector. So here, the main difference in the net zero scenario is the adaptation for the maritime sector. Now, looking at where will the supply come from for hydrogen, and this is here the shares for the net zero scenario until 2050. And we can see that for the moment, there's actually mostly gray hydrogen that is being produced. We saw it on the first graph. There's very little actual green hydrogen being produced. But this already changes quite a lot until 2030. So in 2030, we approximately expect 27% of green hydrogen being produced, still a fair amount of gray hydrogen. And then obviously until 2050, the ambition is not to have gray hydrogen anymore, so it's around 36% of green hydrogen being produced, and mostly it will be coming through imports. The reality is Europe will be relying a lot on imports. We don't have enough renewables, and we have high ambitions around electrification. There's always a trade-off between using the electron for the power sector or for the electrification itself, or the production of hydrogen. So Europe will be building an infrastructure. We expect the imports to be picking up at around 2035. There's a lot still to be done in terms of infrastructure, in terms of building terminals, converting the existing natural gas pipeline, and actually being able to have a liquid market. But until 2050, really, Europe will have a liquid hydrogen market, which will then be able to provide Europe. Now, looking at the pipeline of electrolyzers that we see in Europe, this is based on Aurora's electrolyzer database, which assesses the whole pipeline of different electrolyzers that we see across Europe. We differentiate here between projects that are quite early stage and projects that are already a bit advanced. And what we can see on the right-hand side is that there's a couple of countries in the lead. Germany has by far kind of the biggest pipeline of projects that are in development. So this doesn't actually include these very early stage projects, followed by the Netherlands. There's quite some activity in Spain, and then the UK, also in Germany, though, is really by far the biggest country. But when we see on the right-hand side, when we look at the current project pipeline, is that if you just look at the complete pipeline, it actually looks quite good. So the pipeline is actually larger than the total needed for 2030 with the targets of REPowerEU. However, when you look at those projects that are in development stage that we really believe that can be achieved in the central scenario until 2030, we see that there's actually quite a big gap. So the takeaway is really we need to be accelerating the development of those projects quite a bit in order to get there in time. There's a couple of hurdles that I would just like to mention. I'm sure it has been discussed already quite a bit around the challenges that we see in the EU. On the one hand, the very long lead times for the IPCEI support schemes we see takes around, it can take 2 years or even more to really get the approval for the subsidy scheme, which if you compare it, for instance, to the US, this is quite a long lead time. The next point is around the classic chicken and egg situation around the infrastructure. So infrastructure is not being built if demand is not fully committing, and so this also is leading to some delays. Here again, the situation around the shifting around of the natural gas dynamics is also slowing down the road mapping around the conversion of natural gas pipelines, which then make it also more difficult to plan for the electrolyzer part. The regulatory uncertainty on EU national levels, so here specifically we had a lot of delays regarding the delegated act in the last year, and the EU setting very high requirements around the quality of hydrogen. Here the reality is a lot of the utilities and players are looking into different regions in Europe, only have a certain amount of resources and money that they want to put on the hydrogen topic, and we see some shifts towards focusing on those countries or areas in the world where it's just easier and faster to get those electrolyzer projects on the ground and running. OEM capacities could be an issue if the electrolyzer business really picks up, so really having enough manufacturing capacities in a situation where inflation is high, capex is high. This is also slowing down some of the processes. And last but not least, just the competitiveness of the European hydrogen economy in comparison to other areas. Thank you very much for making the time this morning. It was a pleasure to be here, and I hope that some insights were at least new.
Absolutely. Thanks a lot, Thekla.